Good morning. The next topic that we want to see is discrete time signal. The elementary signal serves as a basic building block for construction of more complex signals. These elementary signals are used to model large number of physical signals which occur in nature. The standard discrete signals are unit step function, unit ramp sequence, unit parabolic sequence, impulse function, sinusoidal sequence, real exponent and complex exponent sequences. Okay. Discrete time unit step function. It is an important signal that is used to set. This is an important signal sent for analyzing of many DT signals. It exists only. It has only one. It has only. I mean, it exhibits only for positive time and zero for negative time. Here, as it shows, for negative time, it doesn't exist. For positive time alone, it exists. So it is called as unit step signal. It is equivalent to applying a signal whose amplitude suddenly changes and remains constant. Amplitude suddenly changes and remains. It will be one for the entire set of time. Okay. In between the discrete and the discrete instant, it is zero. That is, in between these two, the value will be zero. If the step function has unity magnitude, if the step function has, if the magnitude is equal to one, then it is called the unit step function. If the value is two, then it is not unity step function. It is just called step function. This discrete time signal is denoted as U when, and if there's a time shift, then it is defined as U n of n. So this is the function U of n is equal to 1 for n greater than 0. N greater than 0. N is 1, 2, 3, 4. If n greater than 0, it is 1. N lesser than 0, it is 0. So here, if it is shifting, if it is a shifted version of this, shifted to nk minus 1, U of nk minus 1, then it is 1 for k. K greater than k greater, which is 1 or k lesser, then it is 0. The next one, unit ramp function, discrete unit. The discrete time unit ramp is represented as R of n. In sequence, it starts at n is equal to 0. It starts at n is equal to 0 and increases linearly with time. So it increases linearly with time. It is represented as R of n is equal to n. N greater than n is equal to 0 and 0 for n lesser than 0, it is 0. It's called as unit ramp. It starts at n is equal to 0 and increase linearly. If there is a shift, then that is R of n minus k, then it is defined as R of n minus k is equal to n minus k for n greater than 0, for n greater than k. Then there's a shift, and n greater, if it is n minus 2, then after 2 only, the value will start increasing linearly. So this is the graph. Unit parabolic sequence. dt unit parabolic sequence is given as P of n parabolic. So P of n is defined as n square by 2 for n greater than n equal and greater to 0, and 0 if it is lesser than 0. So the same thing is written here. And if there is a shift, then it, as usual, we know, then it's here in P of n minus k over part 2 by 2 for n minus f n k. So this is general discrete function for parabolic. This is for shifted general function after n is n greater than 0, you have value. It increases parabolically. For n lesser than 0, it is 0. If for shifted n is equal to minus 3, so from 3 value will increase. So this is a shifted parabolic function. Then discrete time impulse function. The discrete time impulse function tau is represented tau and is called as unit sample sequence. It is defined as tau of n for n equal to 0 and 0 for n not equal to 0. So only for n equal to 0, only for n equal to 0, that only a single value has 1, others all will, both end will be 0. This means that the unit sample sequence is a signal that is 0 everywhere except for at n is equal to 0. Where its value is unity, and it's widely used in it is a widely used elementary signal used for analyzing of signals in system. Time shifted value is tau of n minus k. So as usual, 1, 0, and then n minus k, n not equal to 0, and n equal to 0, and n for n not equal to 0. The next signal, sinusoidal signal. The discrete signal sequence is given as x of n, a of s sine omega n plus phi, where a is amplitude, omega is angular frequency, and phi is the base angle, and n is the integer value. Here a amplitude, omega angular frequency, phi phase angle, and n is the integer. The period for discrete time sequence, the sinusoidal sequence where n is equal to 2 pi 2 pi by omega in meters, where n is the n and m are integers. For all continuous time signals are periodic, but discrete time signals may or may not be periodic. And depending upon the value of omega, for dt signal to be periodic, the angular value, the dt depends upon their angular frequency, should be a multiple of 2 pi. Then it will be a periodic signal. Real exponential sequence. Discrete time. This is an equation for exponential sequence. X of n is equal to u per n, where n for all value of n. And here we have three cases. We have three cases: a greater than 1, a between a is between 1 0 and 1, and a is lesser than 0. This is positive. This is between. This is for negative values. So when you substitute here, when a is greater than 1, then the sequence will grow exponentially, as shown in figure A. If it is between 0 less than a less than 1, then it is a decaying sequence. Decaying sequence, like shown in figure B. If A is lesser than 0, the sequence will alternatively sign as in figure C and A. Substituting the value of negative values, then if it's an even value, it will be here. If it's odd value, it will be here. So it will sequence between these two. A greater than 1, it will exponentially grow. If it is between these two values, it will exponentially reduce. If it's greater than 0, it will downward between this and this. Complex exponential sequence. Discrete time function. Here, this is an equation for complex exponential sequence. A power n e of j omega j into omega naught n plus 5. Here, if you multiply n, you will get a power n into cos of omega n plus 5, and plus real value imaginary. This is a real value, this is an imaginary value. Here again, we have two cases where a is equal to 1, a is greater than 1, a is lesser than 1. The real and imaginary, if a is equal to 1, the real and imaginary part are sinusoidal. If a is greater than 1, then the amplitude of the sinusoidal wave will grow. So it will grow as shown in A. Then if A is lesser than 1, then the amplitude of sinusoidal is lesser than 1. It means the amplitude will sinusoidally decrease. Thank you.